Alright, so we're going to do a trig substitution integration problem. It is the integral of the fraction 5 on top, and that's all over the square root of 25x squared minus 9 dx. So this is of the type of variable squared minus number squared. So it fits the type where the square root is on the opposite leg. Okay? Now, the x in this form could be anything with a variable that's a square term. So basically, what's related to our x is 5x, because that's what would be squared to give you 25x, and the a would be 3. Now I'm going to do something that I found is a little bit less confusing in some cases. You don't have to do this, but I want to say that a equals 3, and it does. And then I want to say x equals something, but when I say it, I'm going to say x equals 5x. So try and avoid that confusion and leave all this information over here the same. I'm going to change these x's to w's or y's or anything else. So I just changed the name of them. Okay, I changed all my x's to w's, so it wasn't like a real crazy substitution. It's a one-to-one substitution, so everything works out perfect. So in that case, when I say x from my substitution template, we'll say it is 5w. Okay, so I've got those two things in hand. So what type of things do I need to do? Well, I need to be able to replace this square root of 25w squared minus 9. So if I come over here, we've decided from this here that that's going to be equivalent to a tangent. So that means that 3 tangent of theta will equal the square root of 25w squared minus 9. And the other thing I need to replace is this dw, which is dx over here, and that's going to give me a, which is 3, secant of theta, tangent of theta, d theta. Now I've got everything I need to do to complete this substitution. One thing I haven't done that I usually like to do is draw out the triangle and label everything. Since I had the triangle already over here, that's why I neglected to do it, but let me get it. I know that's the scariest looking triangle you've ever seen. But in the way things are, to the angle, the adjacent side is 3. The hypotenuse is 5w in this case. And then the opposite side is 25w squared minus 9. So if we ever need that triangle, and we need to feel that Mr. Allred can't draw a triangle, we have it right there. So let's go kind of change our w's to thetas. So what do we got? We've got, let's match them up here. We've got our square root, which is going to be replaced with 3 tangents. So let's keep what we've got. So we've got 5 over 3 tangent of theta. So you can see where these things come from. And that'll be times dw, which will be 3 secant tangent d theta. Okay, so let's use a different color to make sure we see it. Orange. So we're replacing dw with this equivalent statement. Let's see what's happening. Okay, it did catch up. So now we've got our integration and completely in terms of theta and trig functions. So what can I do? Well, here's a 3 tangent in the denominator, and here's a 3 tangent in the top that I can just wipe out. And if I do that, then I'm trying to integrate 5 secant theta d theta. Now secant is one that has the nicest integration. It's not one that we have memorized. So let me go pull it from a sheet here, and I'll be right back. Alright, so I'm back. So let's see, the integration of secant is the natural log of secant plus tangent. So that's what I'm going to do. I'm going to say that this thing integrates to be 5 times the natural log, let's use some colors to denote the bars here, of secant theta plus tangent theta, all in absolute value, plus c. Okay, now two things. One, we've got to get back to w, and w is really x, so we'll be okay. But let's take this. So, what do? We go back to our triangle. So, 5 times the natural log of the secant of theta. Well, the secant is, let's think, the secant is hypotenuse over adjacent. So that's going to be 5w over 3, I believe. Secant is reciprocal of cosine. Cosine is adjacent over hypotenuse, so it's hypotenuse over adjacent. And then plus tangent. Tangent is opposite over adjacent. So that will be square root of 25 w squared minus 9 all over 3 plus c. Now the only thing that really needs to be done after this is it started in x. I just changed it to w so I wouldn't confuse it with the x's over here for the substitution. So really we will make this thing look like 5 times the natural log. I'm just rewriting it. 5w over 3 plus square root of 25w squared minus 9 over 3 plus c. And this is where having that triangle available becomes very useful, because when you try and take the secant or the tangent, instead of trying to jump back over here or go through your writing just in case a different function comes up, you can just look at the triangle and know where things are supposed to be related to each other. All right, good example.